this is the front page for the exam, paper 2 exam. Actually, make sure when you receive the paper, it's extended, as you can see here. And you know the instructions, still many years without any change, but it's very important to read it before you start. And also make sure that this is the paper that you pay for, like it's 625, paper 2, variant 2, February, March. This is the variant that we're gonna solve right now. And make sure that you have May, June, October, November, or whatever the session you pay for. And the time allowed for this paper is 45 minutes, and there is no reading time. Once when you receive the paper, there is no reading time. It's just the time once the invigilators ask you to start, they will count the time 45 minutes for you. And as you see here, you may use multiple choice answer sheet. It will be given to you in the exam hall. Soft clean eraser. This is please take yours with you. Soft pencil. Pencils are available everywhere, but please take yours with you. It's supposed to be soft to avoid any scratch or over scratch in the paper that you have. The instructions, there is no change unless if you take a look here. The gravity acceleration, we used to use it as 10, but actually starting from this year, we're gonna use it 9.8 meter per second square, right? This is very important. It was 10 before. But the rest of the instructions, it's still the same. Like we have 40 questions, each question awarded 1 mark for you, and we have 4 choices, all of them wrong except 1. And this is what you need to investigate and reach to. Write with soft pencil in the answer sheet. Write your name and center number and candidate number in the sheet provided to you. Write in a clear way. My advisor, write your name and your family name using capital letters and a little space between each name. This is a good idea. You don't have to use correction fluid. That's why you have an eraser, paper 2, so you can use it whenever you change your mind in the answer, so you can choose the correct one. And also the acceleration, as we said, has been changed from 10 to 9.8 meter second minus 2, or meter per second square. The total marks, as you see here, is 40 marks, and each correct answer will score 1 mark for you. And any rough working should be done on this question paper, and believe me, no one will see it, right? So do your rough paper or do your rough working in this paper, and no one will see it. It's just your calculation. If you want to remind yourself by something, it's up to you, but don't write in the answer sheet any scratch or rough work. In question 1, which list contains 2 scalar quantities and 2 vector quantities? Let's discuss about that. Distance, speed, time, velocity. So I'm gonna start with slow rate, then I'm gonna increase my rate when I go over the questions. Like distance here, when it comes to scalar and vector, distance, it's not displacement. So I'm gonna say here, this is scalar. Speed, scalar. Time, it is scalar. Velocity, it's vector, because it has a direction, it's not speed. So again, force, it has direction, velocity has direction, distance is again, and the mass is S. So I'm sure the answer here will be B. So we still investigate the answer C, like mass, scalar, energy, scalar, temperature, scalar, momentum, vector. So it's not the right option because we need 2 and 2. D, this is vector, acceleration vector, momentum vector, and speed scalar. This is how it goes. So the right answer in question 1 is B. In question 2, what we have here, the diagram shows the speed-time graph for a car. The question is, You know, when I see speed time graph, I could know that, and the slope could represent the acceleration, and the area under the graph represent the displacement or the distance covered by the body. So this is what jumped to my mind right now, and I can investigate through it. So they said, which row describes the motion of the car at point X and at point Y? At point X, the speed is increasing, or the body is accelerating with a constant acceleration. So I'm gonna say here, at rest, no. Moving with constant speed, no, it cannot be moving with constant speed, because actually constant here is wrong, because the speed is increasing. As you see, the graph is going up, and the speed is increasing. By passing the time, the speed becomes more. And in C, with changing speed, I can consider this is correct. Changing speed, this is also correct. So C and D, when it comes to point X, both are correct. Let's see at point Y, moving with constant speed. No, it cannot be constant here. Again, wrong. At rest, both are wrong, because the body is moving with a specific speed. You can see that speed here. So we have a speed here, and also by passing the time, this speed getting more. So moving with a constant speed. So I'm gonna say moving with a constant speed at point Y. Yeah, because at Y here, the speed is constant. So depending on that, the body will move with a constant speed. So depending on that, the right answer will be D. In question 3, 4 objects are moving in a straight line. The table shows the distance moved by each object in each second of its motion. So which object is moving with a constant non-zero acceleration? Constant non-zero acceleration, it means the body is speeding up with a constant rate. And actually, when I say distance moved in 1 second, it means all these numbers in the table are velocities, because the definition of velocity, it's the distance covered in 1 second. And they give it to you as a definition, like the distance covered in 1 second. For example, at A here, it's 5, then in the second it's 5, then in the third second it's still 5, in the fourth second still 5. It means my speed still constant, because I cover the same distance during the same interval times. So the speed here is constant, so I can say the acceleration here is 0 and the velocity is constant, if you want to mention that. So A is not the right option in that case. Then at option B, the speed was 5 meter per second, then the speed changed to be 6 meter covered per second, then 7 meter covered per second, then 8 meter covered per second. I can observe, the speed is increasing by 1 for each second. So the acceleration here is 1, and the velocity is increasing. So I think this is the right answer, depending on that. Here, the speed was 5. Now the speed is 7, increased by 2. Then from 7 to 10, increased by 3. So this is not constant speed. So the acceleration, it's not constant. Increasing acceleration. So actually, I will not choose C. So the distance moved in the first second, if it was 5, then 8. Here we have increment in velocity or in speed like 3. And here we have increment like 6. So actually, this is not constant. So again, I will not choose D. So the right answer here is B. Then in question 4, the drag force in a car increases with speed. At 20 meters per second, the total drag force is 40 Newton. The mass of the car is 1,200 kilogram, and the driving force is constant at 700 Newton. So which statement about the acceleration of the car at 20 meters per second is correct? The acceleration is 0.25 meters per second square, but will decreases as the time passes. Actually, I agree with that initially, and we will back to it when I read the rest. Like, think about it. The acceleration is 0.25 meters per second. Yeah, I can understand that. The dragging force on the car increases with speed. So at 20 meters per second, the total drag force was 400 Newton, and the mass of the car is 1,200 kilogram, and the driving force is constant at 700 Newton. So by a little calculation, you can say, the total force acting on the car equals 700, which done by the engine, minus 400, which is the resistance force. This is the dragging force. So it gives you 300 Newton. And lately, you can find the acceleration. So the acceleration equals force divided by mass. The force is 300 divided by the mass, which is 1200. So I can cancel these zeros. So 3 divided by 12, it gives you the number here, which is 0.25 meter per second square, or you can say Newton per kilogram. As you know, this is the same measuring unit for acceleration. So I'm agree with that. Like the acceleration is 0.25 meter per second, but will decrease as time passes. And usually it could decrease because the speed is increasing here. The total dragging force is that. So the mass of the car is, and the driving force is. So actually here, we have an acceleration. That means, the speed of the car increases, and they told you, the dragging force of the car increases with the speed. It's written here. I can just highlight it. And that means, bypassing the time while the car accelerating, the speed will increase, so the total dragging force will increase. It means the opposite force will increase, so that 300 becomes less bypassing the time, so the acceleration becomes less. This is what I need to prove to you, right? So the right answer here, initially, I'm going to choose A. Let's discuss the rest. The acceleration is that's correct, but will increase as time passes. Actually, no sign for the idea of increasing here, because actually there is no sign. There is a more force or more acceleration could be done by the engine. There is no sign for that in the question. So the acceleration is 0.5. No, these accelerations, two accelerations are wrong. So I'm going to choose A in such this question. In question 5, they said rectangular swimming pool is 50 meter long and 25 meter wide. It contains water at a depth of 2 meters. The density of the water is that. What is the mass of the water in the pool? We need to do little calculations here. We can find it using many ways. I could just remind you by density equal mass over volume. So depending on that, the mass, which needed here, equal to density times volume. The density has been given like 1,000 times the volume. We have the volume of the water inside by these 3 dimensions. We have 50, 25, and 2. So I'm going to write here times 50 times 25 times 2. So I'm going to give you the mass, which is density times volume. So by using the calculator to find the answer, you find it's 2 times 100. So it could be 25, and we have many zeros here, like 1, 2, 3, 4. Okay, 1, 2, 1, 2, 3. That's great. So the right answer will be D in such this question. That was easy. In question 5, an object is rising vertically at a constant speed through water. There are 3 vertical forces acting on it. The weight, it should be the weight acting down, and the dragging force, D, and the upward force. So actually the upward force here, which is U, it should act in a direction which is up, right? It cannot be down, by the way. So U here, it's supposed to be up. Yeah, they wrote all in up. So which diagram shows the magnitude and the direction of the vertical forces acting on the object? The key word here, we say constant speed. When they say constant speed, vertically constant speed here, it means the velocity is constant and the speed is constant. It means the total force should be 0, right? So when you add the total force in all that, it should be 0. So let's think about the total force 0 for these answers. So for example, A, and for B, the total force up is 5, down is 1, so I will not choose B. For C, it's 2, up and 1, 3 both acting down, so I will not choose C again. For D, 3 up and 3 down, so I will choose D. So now let's investigate which one is correct, A or D. So they said here dragging force, dragging force D. The dragging force, it is a force against the motion. And they said, the body or the pole is moving up, so the dragging force should be down. So this direction here, it cannot be correct. This direction here, it cannot be correct. So I will not choose A at all, because the direction of the dragging force is wrong. I will choose D. In such these cases, the dragging force acting down, the weight acting down to the center of the earth, and the upthrust force or the upward force acting up, this is exactly what we need. So the total force is 0. That's why it's moving vertically in one direction with a constant speed. So the right answer here will be D. In question 7, it seems like balance. Let's see what we have here. 2 boys of equal weight sit on one side of a seesaw as shown. Their father of weight 1000 newtons sits on the other side. The seesaw is balanced and is being used so that it moves up and down. That's fine. During one part of the cycle, the father descends through a distance of 40 centimeters. So let me write that down. So the father will go down here like 40 centimeters. And on the same time, the boy nearest the pivot rises through 20 centimeters. So here it's going to be 20 centimeters. And while the other boy rises through 80 centimeters. So because of the difference here, I can understand that. So this boy will move higher with around 80 centimeters. That's fine. That's great. Then what is the weight of each boy? They didn't give you the distance to the pivot, so that's why please think in another way. We can find out the distances, but it needs to find some calculations here. I don't like this way. It takes time. But the only way that we can say here, the lose in potential energy for the father, it will be gain for the 2 kids. Like for the father, it will lose energy like mgh. So I'm going to write the mass of the father here is, the mass of the father here is, or mg directly, it's 1000. So I'm going to write 1000 here. This is the weight of the father. This is the weight of the father times the gravity acceleration, so mgh, times the height, which is 40 centimeters. So can I keep using centimeter here? Times 40, equal to mgh for the kids. So I'm going to write here mgh here is 20 for the first kid, plus mg, the same m and the same g for sure, for the second kid. And write 80 centimeters here. So we have one equation with one unknown. It could be great if you find it, like 1000 times 440, it gives you 40,000, equal to mg times 20 plus mg times 80. It gives you directly, when I take mg as a common factor and add them, it gives you 100 mg. So depending on that, the mass of each boy equal to 40,000 divided by 100 times g, and g is 9.81. Please use that. So 40 divided by 100 times that number, I'm gonna give you, if you use your calculator, it could give you around 400. But in this case, we almost use the gravity acceleration like 10. But this is the nearest answer when it comes to the general law for sig fig and decimal places. So I'm going to use B here, because B is the nearest answer. For me, it's a little bit more than 400, but it cannot reach to 600 for sure, right? It's not even 410. So the right answer here will be 400. I hope it's clear. This is the easiest way that we can do here. In question 8, we have a student measures the length of a spring, she then attached different weights to the spring. She measures the length of the spring for each weight. The table shows her results. So this is the original length. And when I add 1 Newton, the length increased a little, and so on for the rest of the weights. So what's the extension of the spring with a weight of 3 Newton? Attach it to it. That's easy. Like, go directly to 3. And the length, when we attach 3 Newton, was 533. Please subtract the original length. So I'm going to say here, the extension equal to the original length out of the total length. So 533 minus 520 going to give you 13 millimeter according to the measuring unit mentioned in the question. So I'm going to choose the right answer here. It could be D, which is 13 millimeter. That was easy. In question 9, the momentum of a body is changed by a force acting on it for a period of time. So when we change the momentum, and the mass of the body stays constant, so I'm going to change the velocity. This is fine. So which action increases the change in momentum? Let me see what we have here. Doubling the force and having the time. Let's see, any momentum equal mass times velocity, right? And that means we have change in momentum, so it's gonna be like if the velocity changes, so the change in momentum equal change in mv, right? Change in momentum divided by time, it gives you the force, and also F equal change in momentum divided by time, so that means m dot v divided by t. So let's see what we have here. So the change and momentum itself equal force times time. This is the impulse. I agree with that. So they said which action increased the change in momentum? Doubling the force and having the time. It means if we double the force and have the time, it means we did nothing. So it cannot be A at all because it gives you the same change in momentum. No doubt, it could be the same. Doubling the force for the same time, yes. Doubling the force for the same time, it means, I'm gonna make this F 2F, and the time is still the same. So in this case, the change in momentum will increase. So initially, you're gonna choose B. In question 9 again, C, having both the force and the time. If we have the force and the time, it will not increase the momentum, it will decrease it. So this is also wrong. Having the force and doubling the time, it's the same effect like A, it gives you no change. So I will not choose D again. So the right answer in question 9 is B, as we choose. In question 10, before we go to a little break, the equation used to find the change in gravitational potential energy for an object can be written as delta EB equal Y times Z times change in H. Change in momentum equal mgh, or mg change in h. M here is the mass, g is the gravity acceleration. So I'm agree with that initially. A is correct. Gravitational field strength, this is correct. Density no. Density no. Speed no. Speed no. Mass no. So actually the right answer, depending on that, it could be A for question 10. In question 11, a machine has a power input of 200 watt and a useful output energy of 1 kilojoule in 6 minutes. So what's the efficiency of the machine? The law of efficiency equal to power out divided by power in times 100. So I'm going to use this. Since, the efficiency equal to the power out, it could be the energy divided by time. So if you're going to calculate it, the energy that has been given, it's 1000 joule divided by the time, which is 6 minutes. And I need to change these 6 minutes into seconds by time 6 times 60. So now we have the power out divided by the power in, and they said the power input was 200, so I'm going to say 200 here. This is supposed to be 1,000. 1 kilojoule means 1,000 joule. So actually now we have the equation ready, then times 100 to find what's the efficiency in percent. So I'm going to do this calculator using my calculator. So 1,000 divided by 6 times 60 times 200. Please make sure that you have fractions in your calculator in order to do that, or be careful when you put the brackets a little down. If you don't have fraction in your calculator, it's a good idea to put brackets here to avoid any misunderstanding for the equation itself. Times 100. It gives me exactly in the calculator 1.388. It means I'm going to go directly and choose C. That was question 11. Then in question 12, what is the unit of power? You know, energy measured in joules, force measured in Newton, potential difference or EMF measured in volt, but the power measured in watt. So I'm going to choose watt here. That was question D. In question 13, the diagram shows a rectangular block of weight 16 Newton. It's resting on a flat surface, and we know the dimensions here has been given. So what's the pressure at the base of the block due to its weight? That's fine. So we have the weight is 16, so I'm going to say the pressure equal force divided by area. The force that we have here is the weight, which is 16 divided by the area. Let's find out what's that area. I have these two dimensions because the area down at the bottom equal to the area at the top for that figure. So I'm going to use 5 centimeter and keep it in centimeter because the answers here has been given in centimeter square. So I'll keep it in centimeter without any change. So it's going to be 5 times 4, so it could be 16 divided by 20. 16 divided by 20, as you know, it's equal to 0.8. So I'm going to go directly 0.8. So I'm going to go directly and choose it from the answer, which is C here. That was for question 13. That was easy. For question 14, they said an oil tank has a base of area 2.5 meters square and it's filled with oil to a depth of 1.2 meter. The density of the oil is what's the force exerted on the base of the tank due to the oil. You know, any force equal mass times gravity acceleration. And we can find the mass depending on the law of density. You know, mass equal density times volume. So let me write that down here. You know, the force, any force equal mass times gravity acceleration. And if we depend on that, I'm going to say the mass here is density times volume. It gives you the mass. Then still times gravity acceleration. So the density has been given 800. This is most probably for olive oil. 800 kilogram per meter cube. Then times the volume. The volume, we have 2 dimensions here. We have, 3 dimensions here. We have the area, 2 dimensions, and we have the depth. So it's going to be 2.5, make sure that it's in meter square, times 1.2 in meter. That was the density times volume, then times gravity acceleration. Gravity acceleration, in my calculation, I'm going to use 9.8, and I will see the closest answer. So I'm going to use my calculator now to find it out. It's in the calculator, it's 23,520. So I'm going to go directly to the closest number for that, which is D. This is what we need to choose. It's very far away from B, and A and C out of the game. So it's 24,000. instead of 23,520 because we are using 9.8, and if you use 10 as what we do before, it will be exactly 24,000. Anyway, they're trying to deliver the idea of uncertainty before you go to the AS level. Let's see question 15. In question 15, they said a sample of gas is trapped in a rigid container. As the temperature of the gas increases, the pressure increases. That's fine if the volume was constant. Trapped in a rigid container, it means the volume here is constant, so the pressure will increase by increasing the temperature. This is normal. Which statement is not correct? And they wrote not here by bold, so don't choose the right answer because we have 3 answers. Maybe all of them are correct, except one is wrong, and you need to choose that one which is wrong. So be careful. The gas molecules have a greater kinetic energy. Yeah, it's correct. So I will not choose it. This is correct, so I will not choose it because the temperature when it increases, so the kinetic energy will increase. So A is correct, but I will not choose it because it's correct. So the gas molecules hit the wall of the container harder. Yes, this is also correct because once when we have more kinetic energy, it's going to move faster. So when it moves faster, it will hit the container harder. Actually, this is also correct, so I will not choose it because it's correct. See, the gas molecules hit the wall of the container more frequently. This is also correct because when the motion becomes faster or when the motion becomes higher, actually they will reach to the other side faster, so it will collide more. It means it will collide more frequently comparing by before. All A, B, C correct, so I will not choose them. Let's test D. The gas molecules move further apart. No. The gas molecules stays the same average distance because the volume is constant. So further here is wrong because the container already sailed or trapped or closed, right? So D is wrong, that's why I'm gonna choose it. Remember, they ask you here for the not correct one. In question 16, what happens when the temperature of a liquid increases? We have many things. The mass of the liquid increases. Actually, it's not related to the mass at all. So the mass here and the mass there, I cannot choose them. Let's test C and D. The volume of the liquid increases, making the liquid less density. I agree with that completely. The idea of expansion. So the liquid or even solid or even any gas, it will expand. Maybe the expansion ratio different between the materials according to the state of the matter, but any matter once when you heat it, it could expand. The volume of the liquid increases, making the liquid more density. No, it doesn't make sense because density equal mass over volume. So the relation between volume and density is inversely proportional. So depending on that, D will be wrong. So the idea more density here will be wrong. So I'm going to choose C. In question 17, a bar of metal, which is good thermal conductor, is heated at one end. What is the main method to transfer of thermal energy along the bar? It's metal. So this is conduction. Yes, I heard that. So it could be conduction. And in conduction also we have some free electrons. Let's see. Less vibration? No, this is a way. Movement of atom? No, there is no movement of atom. Transfer by electrons? Yes, I agree with that. The free electrons through metals could transfer from point to another on the bar. Vibration of atoms of the metal bar, not atoms. Maybe vibration of molecules, but actually it doesn't work here. So I will now choose all of them except C. So the right answer here could be C. Due to the free electrons will carry the energy from molecule to the next, to the next, to the next, until it reaches to the other end. That was 17. In question 18, a transverse wave moves along a rod. The diagram shows the position of a rod at one particular time. Which two label points are one wavelength apart. I can understand that. I think it's X and Z because the beginning of trough and the end of the next successive crest, these are the wave. So I'm gonna choose this from X to Z. So the right answer here is C. This is great. Actually, any other option here, it will be wrong according to the wavelength. So the right answer here, it's supposed to be C. In question 19, a light and transparent plastic meets a boundary with air. Light is transmitted into the air only if the angle marked theta in the diagram is greater than 36. Be careful because this angle for you is nothing, it's just in the question. But this is not the incident angle, by the way. So what is the refractive index of the plastic? Again, they said here, if the angle marked theta of the diagram is greater than 36. So actually here, if that angle greater than 36, it means the light transmitted into the air only if the angle marked theta in the diagram is just greater than 36. So if that was 36, it means, the incident angle will be 90 minus 36. Think about it. The incident angle, it's the angle between the normal and the incident ray. So we are right. The normal makes 90 degrees and the theta is 36. So the incident angle in that case, it could be 90 minus 36, which is 54. So the angle here is 54 degrees, right? And I'm going to consider 54 degrees, this is the incident angle. And to find the refractive index, I'm going to say N, the refractive index, equal to sine 90, which is, let me write it, sine 90 degrees divided by sine 54 degrees. Keep in mind, sine 90 is 1 if your calculator was in a right mood, which is degree, not rad. Make sure that there is a little d at the top of your calculator. That means in your calculator in degree mood, not in rad mood. Then divided by sine 54. So when you say n equal 1 over sine 54, it gives you directly in your calculator 1.2. So I'm going to choose C. This is how it looks like, right? So equal 1 over sine 54 degrees, it gives you 1.2. And 1.2 here gonna be without any measuring unit because there is no measuring unit for any ratio. Then in question 20, a thin converging lens has a focal length f and object O is placed to the left on the lens as shown. Fine. Where is the image formed and how does this size compare to the object? How does its size compare to the object? Fine. Actually, once we are in a distance less than f, so the image will be formed on the other side. I can complete it with you, but you don't have to do that during the exam. So the image position, it could be in the same side. So I'm going to choose same side here, C and D. And the image size, it will be larger. So depending on that, the common right answer is C. So I'm going to choose C. That was fast. But if you, a kind of revision, I can complete the figure with you here, right? Any ray parallel to the principal axis, it will reach to the lens, then it would refract passing through F itself. So here. And I'm going to take another ray from the same point, and this ray could pass through optical center. As you see, these two rays will never meet each other forward, so we need to continue the figure until they met each other backward. And it's a good idea to keep the extension of the ray dotted line like this one, right? And I'm going to extend the other ray here. And I'm going to keep it also dotted. As you see, the image will be formed exactly here. So this is the image. As you see, it's on the same side and larger than the object. And this is the position of the eye. For A1, need to take a look for that object and see it larger, like what we usually have. In question 21, which diagram shows what happens when a ray of white light passes through a prism? Actually, this question is very, very old, so I'm gonna choose directly D. This is the right answer when it comes to these questions, because actually here the mistake is I have no reason why we have no refraction here. This is wrong. And for that, the rays here refract to inside the glass to be away from the normal, and actually this is wrong. It's supposed to be closer to the normal because the speed was reduced, because the speed initially in air was maximum. So this is the mistake here. And in that section, we have the same mistake here, a B. So it could be refract to be away from the normal, not closer to the normal, because the speed increased. So that direction is wrong. But this is the right answer. Actually here, the position is correct, and in that section, the position is correct. So I'm gonna choose D in this question. In question 22, a television TV station transmits a signal to a television receiving dish. The television has an on-off indicator light. The television is switched on by a remote control, which change the indicator light into red to green. Which electromagnetic wave used in these actions has the longest wavelength? Okay, let's see. So from TV station to the satellite, then from the satellite to the receiving dish, and then from remote control, then we can see here the red and green. So they mean the order according to the longest wavelength. It means the smallest frequency that we have. So to the best idea here, just put in mind which one is the longest wavelength and the smallest frequency. It's actually, if you see the prism, if you see the electromagnetic radiations in prism, you will find the longest wavelength on the smallest frequency will be for the idea of long wave and medium wave and microwave, right? So and the highest frequency here, for example, red has a high frequency comparing by the microwave, and green has a higher frequency comparing by red, and the remote control working with infrared, which has a little bit smaller frequency comparing by red. So it's a good idea to memorize them in order. And the longest wavelength and the smallest frequency that we have, it's in the upper part in the prism, which contains the long waves, medium waves, short waves, microwaves. All of them have longer wavelength comparing by the visible light and the X-rays and gamma rays, and even the infrared. So that was question 22. In question 23, students makes a list of some applications of waves. So medical scanning of soft tissue, stirring water, sterilizing water here. It's four waves. If it has a higher frequency, we can use it in such this practice. Using sonar to calculate ocean depth. That's fine. So let's see which applications used ultrasound waves. Ultrasound waves usually used in medical scanning of soft tissue. Yes, this is correct. For ultrasound, we can see, for example, the size of the baby inside the mother's abdomen using ultrasound, and it's more safe. It's very safe. And also we have, no, it's not. Sterilizing water here, it's not for that. So using SUNA to calculate the ocean depth, yes, we can use it because it's very high speed in water, so it could be go and come back, so we can find the time. During the speed, we can use it to find the depth. So also 3. So I'm gonna choose 1 and 3, where 2 is wrong here, 2 is wrong here, and 2 is wrong here. So I'm gonna choose C in such this question. That's fine. In 24, the diagram shows a bar magnet at rest on a smooth horizontal surface. A length of soft iron wire is held parallel to the magnet. Fine. The wire is released. What happens? Actually, the wire, when it released, it gets attracted to the magnet. So let's see, the wire moves away from the magnet. Repulsion here, it doesn't happen between iron, normal iron, and magnet. No, there is no repulsion. The wire moves towards the magnet because of the attraction. The wire's center stays in its present position, and the wire rotates. No. Rotation here, the idea of rotation here is wrong. Both are wrong. I have no reason, because actually whatever the piece of iron, it could be attracted to N and also attracted to S, so there is no reason behind the idea of rotation. So the right answer here, it will be 24. In 25, said which diagram shows an electric field pattern and a direction around a positive point charge. Positive, it means the field coming out and the direction is out of A. So I'm going to choose it like it's A. So this is the right answer. No doubt, it's A. The direction here is wrong, and the idea of a rotation here is wrong. The idea of rotation here is wrong. This could be if we have a wire, not a positive point charge, right? In question 26, we have a laboratory has standard wire of unknown resistance. It also has other wires made from the same material as the standard wire, but of different length and diameters. Which wire would definitely have the resistance of less than the standard wire? If it was shorter and thicker, if it has less resistance, if it was shorter and the diameter larger to make it thicker, in this case, the resistance will be very, very small. So in 26, no doubt, I'm gonna choose C. As you know, the resistance itself equals resistivity and length divided by A. This A, we could change it into by R square. And R here is the diameter divided by 2. So I'm gonna choose the highest resistance, the highest radius or the highest diameter to reduce the resistance, and the shortest wire to reduce the resistance again. So the right answer here will be C. In question 27, the graph shows a relationship between the current in a circuit component and the potential difference across it. The graph has a straight section and a curved section. Fine. What happens to the resistance of the component in the two sections? For example, in the straight section, because the slope is constant, so I'm going to choose constant. So no change. But in the curved, be careful, because we have an idea here. In the curved part, if we draw a tangent here the slope, and here also we have another slope. So by passing the time, the slope is decreasing. So the slope is decreasing, and the slope here represent I divided by V, or current divided by B. It means it's not R, it's 1 over R. So if 1 over R get decreased, it means R itself is increasing. So the resistance here in the curved part is increasing. So I'm going to choose the resistance increasing in both these two sections. So depending on that, the common correct answer, it's supposed to be D for 27. That's great. In 28, they said the diagram shows a part of a circuit. What is the combined resistance of the resistor? Please try to not use your calculator that much fast. But we can say, for example, here we have 1 resistance equal to 3 ohms. This is the value of the resistance for that resistor, 2 resistors when we add them together because they are series. So 3 ohm. So to find the total resistance or the combined resistance right now, I could use this law, 3 times 4 divided by 3 plus 4. 3 times 4, it gives you 12. 3 plus 4, it gives you 7. So 12 divided by 7, it gives you 1 point something. So I'm going to go directly to 1.7. The right answer here, it's supposed to be C, according to the calculation, right? So that's 1.7 ohms. That was easy. In question 29, the diagram shows a circuit which includes 2 resistors and a battery. Fine. The voltmeter reads 6 volts. What is the potential difference across the 30 ohm resistor? Okay, let's see. You know, we have here, you can find the current, right? First of all, you can find the current passing here, and the current is the same in all circuit. But we can use the idea of ratio. I like the idea of ratio here. If the potential difference 6 around 10, so it means the potential difference here, it's supposed to be 6 times 3, which is 18 volts. So I'm gonna go directly and choose 18. But if you don't like this idea, we could go formal, throw some laws. First of all, find I in the circuit equal to V divided by R. So V divided by R. V here is 6 divided by R, which is 10. So it gives you 0.6 ampere. If we have 0.6 ampere in the circuit, it means we can find the potential difference across the 30 ohm resistor by applying this law. It's I dot R, right? It's the same current because it's series circuit, so the current here is 0.6 times the resistance, which is 30. It gives you directly 18 volt. So I'm gonna go again and choose 18. This is the 2 ways, but I like the idea of ratio because it saves your time. In question 30, so here we have some electricity could be generated because I don't have any source of electricity. So a wire is moved down in a direction perpendicular to the magnetic field. So the wire will cut the magnetic field lines, and depending on that, there is some current will be produced in the wire, or a potential difference will induced. 3 chains are suggested. The speed of movement of the wire is increased. That's fine, to increase the potential difference and the current. The magnetic field strength is decreased. This will decrease the potential difference induced. The direction of the magnetic field is reversed. This will do nothing for us. It will just reverse the direction of the movement for the wires of that meter, right? Instead of moving right, it will twist to the left. Which change increase the EMF induced in the wire? Actually, yes, the speed of the movement, will increase the rate of cutting. So it could be only 1. 2, the magnetic field strength is decreased. No, it will decrease it. So I can see here it's only 1. So depending on that, I'm going to choose B for question number 30. In question 31, a wire is moved across a magnetic field. This causes an induced current in the wire, exactly as the previous question. The induced current interact with a magnetic field to produce a force on the wire. In which direction is this force? It could be act in the opposite direction of the motion. This is according to Lenz's law. So in the direction of the current, in the direction of the movement of the wire, no. It could be in the opposite direction of the movement of the wire. And this is because actually in this case we need to use our right hand instead of left, or left instead of right, to find out the force. So we have a force acting in the wire to produce a current. This current has a magnetic field. This magnetic field will interact with the magnetic field of the magnet to produce another force acting in the wire to opposite its motion. And actually that was Lenz's law. C, in the opposite direction of the current. No, in the opposite direction of the movement of the wire, it will be D. Without any further explanation, I want you to understand In case of generator, when I move the wire will cut the magnetic field lines, then there is a current produced. Up to this moment, it's fine for current. And we can use the direction or the rule of our right hand to find out the direction of the current produced. But that current produced, it has a magnetic field, and it will be act as a motor, right? That current, when it produced, in this case, I need to use my left hand in order to find the direction of the force caused by this induced new current. And you will surprise that it will be in the opposite direction of the motion of the wire. This is what we call it Lenz's law. So keep in mind, any current produced in the generator, it will produce a force opposite the direction of the motion of the coil rotation in the generator, right? That's why the efficiency of any generator cannot be reached to 100%. Anyway, that was question 31, and the answer is D. In question 32, 100% efficient step-down transformer is primary voltage VB and primary current IB, which row combines the secondary voltage with VB and the secondary current with IB. So let's see. They said here step down. Step down, it means the potential difference should reduce. As you know, we are talking about step up or step down. We are talking about the potential difference produced. So if it was step down as this question, it means the product potential difference will be less than V primary. So I'm gonna choose less here. So the right answer will be less. And because the power is constant, so if we have less V, we have more I. So also I'm gonna choose greater I here. So the right answer here will be C. Remember, VP times IP should equal VS times IS. This is if it was primary and secondary, right? Yes, this is what we mean. Primary voltage VB and primary current IP, which row compares the secondary voltage, yes, with these values. So the secondary voltage will be less because it's step down, and depending on that, the current produced will be much more because we reduce the potential difference, so the current produced will be more because the power is constant. As you see here, this is the power, and it is constant because they mention, it's 100% efficiency, so the power here is constant. Depending on that, I'm gonna choose C. That was 32. In 33, the scattering of alpha particles by a thin metal foil supports the nuclear metal of an atom. Okay, fine. This is an experiment done by Rutherford. Why are alpha particles used rather than neutrons? Let's see the reasons behind that, but I'll tell you after the answers. So because they always travel more slowly. No. Listen. Neutrons here neutral, so you cannot accelerate it. Like remember, in Rutherford experiment, we could put that room, and inside it we have helium, which is 2,4. And once when we rise the temperature using, for example, heating element over here, so this is heating element, so the helium will get hot, and the atoms of helium will get exciting. And actually, I charge that with positive, so the electrons will get attracted, and the helium without electrons will be repel and get accelerated outside the room. So actually, helium without electrons, it gives you alpha. That's why we choose the alpha. But in case of neutron, you cannot accelerate it because neutron is usually neutral, right? This is the reason. So let's see what we have here as an answer. They said because they always travel more slowly. We don't have reason for that. Because they are heavier, it doesn't make sense. We need heavy or light. We need to just let them pass through the gold foil. That was Rutherford. B, because they are larger in diameter, it will be more difficult for them to pass through the foil. So this will make the problem more complicated. So I will not choose C. D, let's see, because they have a positive charge. Yes, so you can accelerate it as we just explained. So the right answer here will be D. An iron nuclide is represented by the symbol shown. This is iron, which is 2656. This is the mass number, and this is the most stable element up to this moment I know. I'm not sure about my chemistry, but this is very stable because even the idea of fission and fusion, they are all atoms, bigger or smaller, try to reach, to be closer to the state of iron, to be more stable like iron. So let's see what we have here. Which statements about the nucleus of this iron nuclide are correct? Let's see. The nucleus contains 65 neutrons. No, neutrons plus protons, so neutrons here is wrong. It's supposed to be neutrons plus protons. The nuclear number is 30. When you subtract it, it gives you number of neutrons, but this is not nuclear number. Nuclear number is 56. No, this is also wrong. The proton number is 26. Yes, the proton number is 26. So depending on that, I'm gonna choose D. That was very easy. That's 34. 35. A sample of radioactive isotope has an initial rate of emission of 1 to 8 count per minute and a half-life of 4 days. Fine. So how long will it take for the rate of emission to fall to 32 counts per minute? Let's say how many half-lives that we have, right? I will go with very small idea, like 1 to 8. After one half-life, it becomes 128 divided by that, it gives you 64. Then after more half-life, the 64 will be divided by 2, it means 32. And this is what we have. So we have 2 half-lives, and each half-life 4 days. So I'm gonna go directly and choose 2 times 4, it gives you 8 days. I think that's very easy. We have many laws, we will study them in A2 later on, but actually to go normal like this, easy way, it's much easier. 36. Several scientists are working in a laboratory. The scientists are experimenting with sources which emit ionizing radiation. Each scientist is given a list of safety rules. 3 of the rules are shown. Keep at least 2 meters away from the other people. From the other people, no, because the people usually safe. But actually, from the sample itself will be much fine, right? If it was. So I'm not agree with 1. Do not stay longer than 4 hours per day in the laboratory. Yes, this is because of the dose, so I can agree with that. Stay behind the LED line screen. Yes, because the LED, it could absorb alpha and beta and a lot of gamma. So the idea here for the safety precautions, 2 and 3 work. They are working, but actually 1 here, I have no reason to choose 1. So which safety rules are for protection against the effects of ionizing radiation? Actually, I'm gonna choose 2 and 3 only, because I couldn't see or couldn't feel no 1 could help at all. So 1 here is wrong, 1 here is wrong, 1 here is wrong. In question 37, which data is needed to calculate the average orbital speed of a satellite around a planet? Orbital speed, it needs to know the pathway, so we need the radius, we need many things on that, we need the radius, and we need the time. That's it. So we need the radius and the time. Let's see. The distance of the satellite from the center of the planet. This is the radius, I agree with that, and also agree with that, also agree with that. So the answer is A, or B, or even D. So the radius, yes, the radius is needed. So the answer here is correct. So actually, the radius of the planet, no, the radius of the planet, no. So I'm agree with this. The radius of the planet, it's not important. I mean the radius of the pathway. The distance of the satellite from the center. Yes, this is the radius of the pathway. This is correct for the first column here. But for that column, the radius of the planet, it doesn't make any sense. Even it's not used. The period of rotation, yes. The period, we need the period of rotation, of rotation of the planet or the time. The period of rotation of the planet itself, it's important to find the day on the planet, but actually, I agree with that, it's not needed in such this calculation. So the time for the satellite to orbit the planet once, yes, we need the periodic time, which is t cap. So depending on that, the right answer, as you see here, will be B. Remember to find the average speed. So speed equal to, let me write the speed here. Speed equal to the whole pathway, which is the circumference. I'm gonna write circumference equal to by r. So this is the radius of the pathway here, divided by the periodic time. Periodic time, it's that one. Periodic time. That was easy. And pi is a constant ratio, so it's nothing. So, but the period for rotation for the planet and the radius of the planet itself, it doesn't make any change with me. In question 38, approximately how long does it take for a moon or for the moon to take one complete orbit of the Earth? We said that this is the Arabic month, and actually it's approximately 28 or 29 days, most probably. So I'm gonna choose B here. It's 1 month. This is the one Arabic month. For 39, the energy generated in stable stars comes from a nuclear reaction. Fine. Which type of reactions occurs in the sun? You know, in the sun, we have a reaction which is helium. We have no helium. Helium again, no. Let's think about hydrogen. So helium here, no. Hydrogen nuclei break up to give helium nucleus. No, this is wrong. Break up here is not correct. Helium cannot break up to give you helium. It cannot be accepted. But hydrogen nucleus join together to form helium. If you think about it, this is hydrogen 1,1 and this is helium, which is 2,4. So you know that two hydrogens could be joined together to form helium. This could be accepted, and actually this is the idea of the process, which is fusion, right? Which is correct. But for C, it cannot be right. So the right answer here is D, because the hydrogen nucleus could be joined together to form helium nucleus, and that will make it very close to the iron or a little closer to the iron to be more stable and so on. This is the idea of fusion process that happens on the sun, and this is the reason why the sun is not finished up by passing the time. The last question in the exam was 40. Two quantities define the Hubble constant, H node. The speed at which the galaxy is moving away from the Earth is V. The distance of the galaxy from the Earth, D. The relationship, let's find out the relationship between them on the law itself. So I'm going to say V is proportional to D. I'm agree with that, totally. It's proportional to D. If you take a look for the law, it's directly proportional. And the current estimated for H, what it should be, 2.2 times 10 power negative 18, 2.2 times 10 power negative 18 per second. Yeah, both here will be correct. But this is the speed of light. It's not here. These two numbers, correct? But you don't have to memorize this. Proportional to 1 over d. No. Actually, I know the answer. I don't know the numbers here. I don't memorize them. But actually, the answer here is the only correct is V is proportional to D. So when we have more D, we have more velocity. And that is the key for the answer. So depending on that, I'm gonna choose A.